We have to find the square root of I. Take solution. Recall that under complex numbers, the square root of -1 is equal to I. Finding the square root of I simply means we have to look for the square root of -1. This is what we are looking for. For us to answer this question, we are going to start by saying let the square root of I to be equal to I is a complex number. The square root of I must be a complex number. We are going to let it to be A plus IB, where A and B belong to the set of real numbers. The square root of I equal to A plus IB. Then, if we square both sides, the square root of I, all this squared will be equal to A plus IB, all this squared. Then, the square root of I, all this squared gives us I, to be equal to squaring A plus IB squared. This will give us A squared plus, we take 2 times A times IB. This will give us 2IAB plus IB squared. This will give us I squared B squared. Then I will be equal to A squared plus 2IAB. I squared is simply equal to, if we square both sides here, I squared will be equal to -1. -1 times B squared gives us minus B squared. Then I will be equal to, we are going to bring the real parts together, A squared minus B squared plus, we keep the complex part, which is 2IAB. I can be expressed as the real part is 0 plus I is equal to A squared minus B squared plus, you can express this as 2AB in brackets times I. The left hand side being equal to the right hand side, it simply means the real parts are the same, they are equal, the imaginary parts are equal. This will imply that A squared minus B squared is equal to the real parts 0, and for the imaginary parts we are going to equate I to 2ABI. This will give us 2ABI to equal to I. Then if we transfer B squared to the right hand side, negative B squared to the right hand side becomes positive. A squared will be equal to B squared, and dividing both sides by I here, it gives us 2AB to be equal to 1. Then A squared equal to B squared, it simply means A is equal to B. 2ab is equal to 1. Next, we put in a equal to b into 2ab equal to 1. That is, anywhere we see a, we have to replace a with b. This will give us 2b, replacing a with b, 2b times b is equal to 1. Then 2b times b gives us 2b squared is equal to 1. Then we divide both sides by 2. This will give us b squared to be equal to a half. Then we have to take a square root at the left hand side and at the right hand side. The square root of b squared will be equal to the square root of a half. Then the square root of b squared, it simply decides the magnitude of b, and the magnitude of b will simply be equal to plus or minus the square root of a half. The square root of a half, we can break this as the square root of 1 over the square root of 2, which is the same as 1 all over the square root of 2. Rationalizing the denominator, this will be equal to the square root of 2 all over 2. If you multiply the numerator and the denominator by the square root of 2, you're going to obtain the square root of 2 over 2. So this will give us plus or minus the square root of 2 all over 2. This will imply b is equal to the square root of 2 all over 2, or b is equal to negative the square root of 2 all over 2. Next, we have to find a. For us to find a, we know that a is equal to b. For b equal to root 2 over 2, comma, a will be equal to root 2 over 2. For b equal to negative root 2 over 2, comma, a is equal to negative root 2 on 2. Now we can write the square root of I. The square root of I will be equal to, we are going to replace a and b with their respective values. This will give us the first one, we take root 2 over 2 for a, plus ib gives us root 2 on 2i. You see that root 2 over 2 is common. Factor root 2 over 2 times 1 plus I. This is the first square root. Then we write down the second square root. The second square root of I will be equal to a equal to negative root 2 over 2, negative root 2 on 2 plus, we replace b with negative root 2 over 2 times I. This will simply be equal to, we can factor out negative root 2 over 2, negative root 2 over 2 times 1 plus I. It simply means the square root of I, we can write it as such, Therefore, the square root of I is equal to plus or minus root 2 over 2 times 1 plus I. It simply means that if we square root 2 over 2 times 1 plus I, we are going to obtain I. And if we square negative root 2 over 2 times 1 plus I, we are going to obtain I. Let's verify and see. Let's take the verification. First, we have to square root 2 on 2 times 1 plus I. This will be equal to root 2 squared all over 2 squared times 1 plus I all this squared. And this will be equal to root 2 squared gives us 2 all over 2 squared gives us 4 times 1 plus I squared. 1 squared gives 1 plus we take 2 times 1 times I plus 2I plus I squared. I squared gives us negative 1. This will simply be equal to 2 over 4 gives us a half times adding the real parts. 1 plus negative 1 gives 0. 0 plus 2I will be left with 2I. A half times 2I is simply equal to I, which proves the fact that the square root of I is equal to root 2 over 2 times 1 plus I. Next, let's square the second square root, which is negative root 2 over 2 times 1 plus I. This will simply be equal to negative root 2 squared all over 2 squared times 1 plus I squared. This will be equal to negative root 2 squared. It gives us 2 all over 2 squared gives 4 times 1 plus I squared. 1 squared gives us 1 plus 2 times 1 times I, 2I, plus I squared, which is negative 1. This will simply be equal to a half times 1 plus negative 1 gives 0 plus 2I. A half times 2I is simply equal to I. Therefore, the square root of I is equal to plus or minus root 2 all over 2 times 1 plus I. We are done with the solution. If in case you have any worries, feel free to drop your questions at the comment section. Please, if you like the video, share and subscribe to this channel. Thank you very much for watching.